So I'm going to model part B for you, and then you can work on the others on your own or with a partner or two. So we want to write an equation for a line with a slope of 3 that goes through the point -2, 4. We're going to use slope-intercept form, y equals mx plus b. And then if we look at the given information, we do have the slope given to us, it's 3. So we can rewrite the slope in place of the m in the equation. So we can rewrite the equation as y equals 3x plus b. The coordinate pair that we're given is not the y-intercept, it's not the b value, because the x-coordinate isn't 0. So we need to solve for the y-intercept, and we'll use this point to help us do it. So remember, in a coordinate pair, the first coordinate is the x-coordinate and the second coordinate is the y-coordinate. So now we can use this specific x value and put it in place of the x variable in the equation. We can use the specific y value and put it into the y in place of the y variable in the equation, and then that leaves one unknown of b to solve for. So I'll rewrite the equation with 4 in place of y, and in place of x, -2. And now all that's left is to solve for b. I'll multiply 3 times -2, which is -6. And to solve for b, I would add 6 on both sides of the equation. And then we know that b is equal to 10. So now that we have our slope and our y-intercept, we can write an equation in slope-intercept form. Y equals 3x plus 10. To verify that it works, I could substitute this coordinate pair back into the equation to make sure that it works. So if I put -2 in place of x here, 3 times -2 is -6, and -6 plus 10 is +4. So I do want to help you get started on part C. We're supposed to write an equation for a line that goes through the points 3, -1, and -2, 4. We are going to use slope-intercept form, so y equals mx plus b. In order to write our final linear equation in this form, we have to have the slope and the y-intercept. We are given neither of those pieces of information. Since we do have 2 coordinate pairs, we can start by calculating the slope. So the slope, m, remember, is equal to the change in y over the change in x. If you haven't seen this before, or if you don't remember, this triangle here is the Greek letter delta, and delta we use as a short way of writing the words change in. So this delta y over delta x just means change in y over change in x. To calculate the change in y and change in x, we use subtraction. Typically, we take the second y coordinate and from it subtract the first y coordinate, and that goes on top of our fraction. So 4 minus -1. And then on the bottom we put the change in x, so we subtract the x values, and we have to subtract it kind of in the same order. So we're going to take the x value from the second coordinate pair and from it subtract the x value from the first coordinate pair. So -2 minus 3. And then we just have to do the calculation. 4 minus -1 is 5, and -2 minus 3 is -5. And then by dividing 5 by -5, we get a slope of -1. And then this problem really kind of turns into one very similar to part B. We can put the slope into the equation, so replace the m with -1. And then we are left to use one of our coordinate pairs to help us solve for the b. So you could choose either coordinate pair. If you use the first coordinate pair, you would substitute -1 in place of y and substitute 3 in place of x. And then you would be left to solve for b and then rewrite the final equation using our slope and the b value that you solve for.